Hello, my name is Tianjiao Wang. For this deliverable, I'm presenting with Li Xu on behalf of our team about our project, Predicting Disposition Destination in Hospitalized Stroke Patients. In this presentation, we will summarize our project in the following aspects. We will particularly explain the machine learning, predictive model, and the web app respectively. First, according to the project instructions, the aim of the project is that in the first 24 hours of stroke patient's admission, accurately predict the likelihood of discharge to specific disposition destinations such as home, SNF, AMA, etc. So basically, the requirements are twofold. First, we need to develop a predictive model using machine learning based on healthcare database in the population of patients with acute stroke. This involves data preparation, model training, and validation. Second, we need to develop and deploy a web app that incorporates the predictive model, receives user inputs, and outputs the results using data visualization. And this involves typical software engineering methodology, including requirement gathering, system analysis and design, coding, deployment, test, and delivery. For the complete timetable and current status of the project, you can check the next slide or the following link showing the updated Gantt chart. There are two parallel branches. The machine learning model is led by Chen, Jing, and Li. The web app is led by Borei, Qingliao, and Tianjiao. The detailed task assignment and timeline is shown in this chart. So far, all the milestones have been met on time. Next, we will explain the model and the web app in details.
Hi, my name is Li Xu. I will be walking you through how we built the predictive model. For this, I will divide my presentation. Here is a summary of research literatures that we refer to during this project. We use data from MIMIC, short for Medical Information Mart, for intensive care. It is a large database comprising information related to patients admitted to critical care units. It contains very rich patient information, including vital signs, medications, lab measurements, notes, and etc. All of us was trained to gain access to MIMIC when we started the project. Our goal is to predict the disposition destination for stroke patients using information available in MIMIC during the first 24 hours after patient admission. Possible destinations include home or home health care, meaning home with outpatient therapy referral or home health aside. Also, long-term care hospital, rehabilitation or distinct part of the hospital. SNF stands for Skilled Nursing Facility or DAD. As some patients need referrals to rehabilitation or special care, from the hospital's perspective, it is necessary to identify their disposition destination early on. For data pre-processing, first we need to clean up the data as medical records tends to be disorganized. We picked 1,468 stroke patients from 25,000 ICU stays with ICD-9 codes start with 434. We also excluded recurrent patients, as this leads to ambiguous predictions. Out of 28 tables from MIMICS, we decided to look at tables including patient basic information, ICU-related records, lab tests, microbiology tests, and lab notes. We joined those tables with hospital admission ID, which is a unique identifier for our case. We also transformed categorical features into binary ones. For example, marital status may include single, married, divorced, and so on. After conversion, they will become single or not, married or not, divorced or not. So after several iterations, by talking with our mentor, we finally narrowed down to 12 features to generate our final model, including age, gender, marital status, language, religion, ethnicity, and information for the hospital stay. Then we randomly shuffled our data and saved 20% as test data for final evaluation. We tried a lot of machine learning models. Out of all these models, SVC or support vector classifier trains the slowest and use a lot of computational resources. XGBoost and random forest are quite similar, with random forest perform slightly better. Here are the ROC curves with random forest classifier. And most of the categories, the AUC is above 0.9, which is pretty good. We also try to optimize our model by using research for the best parameters, or try regularization to limit overfitting, and also weighting of imbalanced datasets. All those optimizations are using cross-validations for comparison. The accuracy of prediction with our model is 0.72. Since we have imbalanced datasets, we also care about recall and precision and F1 values. When we look at the confusion matrix, the diagonal elements show the number of correct classification, and the off-diagonal elements are misclassified. We can see that for rehab DPH, it tends to be misclassified, and the reason may be rehab DPH is already a mixture of labels. If we can further split labels, we're likely to achieve higher prediction accuracy. Now, I will hand it over back to Qianjiao again.
Okay, so now we have the machine learning model, and then we can make a web app that incorporates the model. First of all, we gather requirements from our TA and external mentor, which is also the potential user of this product. As you can see here, the main requirements are well documented and listed as follows. The web app uses a typical browser server architecture. For the backend, we use Python and Flask to code the model and the server, and use Python Anywhere, a commonly used commercial solution, to host the model and the service. For the front end, we use HTML, CSS, JavaScript, and Twitter Bootstrap to polish the user interface. And as you can see here, we can directly code our Python programs and upload all the related files onto Python Anywhere for web and model hosting. In the next two slides, I'm going to show you how to use the app. A user can access the app at this link from any web browser, for example, on a desktop computer, tablet, or mobile phone. The logic of the app is quite straightforward. The user inputs patient's data and hits the predict button, and then the app outputs the predict results for the user. As you can see here, there are 12 inputs, which are identified most significant in the model, and it's very simple and intuitive for the user to input all this data. When the user inputs all the patient's data and hits the predict button, the outputs are shown at the bottom of the page. The first part shown on the left here shows which patient we are looking at. The second part shown on the upper right here is a table showing the predicted destination with different possibilities. The third part visualizes a table using a pie chart. Different destinations are labeled with different colors, and the chance of any particular destination is shown when the cursor hovers upon that destination. To conclude, considering the simplicity of our solution, the accuracy is acceptable. In the future, well, possibly another project in next semester, one may consider to use another healthcare database as supplementary, or to try to include NLP for improvement, or to make better UI to improve user experience. So that's all for our presentation. Thank you very much and wish you all Merry Christmas.